So this is the circuit of an OR gate which we built in our earlier video. Now we know that an OR gate is nothing but a NOT gate connected in front of an OR gate. So what we'll have to do is just replace this LED and connect the base of an NPN transistor here, because the NPN transistor acts as a NOT gate. So we just disconnect this LED from here, select a transistor, NPN transistor, this one, and connect its base here. Change the value of this resistor to 1 kilo ohm. Ground its emitter terminal. Now select a DC voltage source, change its value to 5 volt. Connect its positive terminal to the collector. Now select the ground and ground its negative terminal. Select a resistor, connect it here. But change its value to 100 ohm. 100 ohm is enough. Okay. Now connect your LED here at the collector terminal and ground its another terminal. Now here logic is 1-1. Let's see what happens. For 1-1 I am getting 0 output. That means for a NOR gate 1-1 gives 0. If I do 1-0 I should get 0. Here you can see for 0-1 0. Let's see what happens for 0-0. For 0-0 I am getting output 1. For a NOR gate 0 plus 0 means 0 and NOT gives 1. Okay, for 1-1, 1 plus 1, an OR gate gives 1, but a NOT gate ahead of OR should give it 0, so 0. For 0-1, 0 plus 1, 1, and NOT gate gives 0. For 1-0, 1 plus 0, 1, and NOT gate gives it 0. If 0 volt is given at P terminal of a diode, it acts like an open. If 1 is given, it acts like a short. So right now I have given 0-0 logic to both diodes. That means this is open and this is open. These both are open. That means here I am getting 0 volt. 0 volt here means transistor, the base of the transistor is at 0 volt. That means it acts like an off switch. That means transistor is off. You can say that the transistor is not here any longer. So all the current just passes through this LED and LED blinks. If I give 0-1, this diode is open, the circuit is open, but this diode acts like a short circuit. So the 1 logic comes here and your base of the transistor gets some voltage, due to which your transistor acts like an on switch. That means all the current through the battery goes through the collector and then to the emitter and then to the ground, and that's why your LED is off. If I give 1-0, the same thing happens, but just reverse of that. That means this diode is open but this is short. If I give 1-1, this diode acts like a short. This diode also acts like a short. That means the base of the transistor gets some voltage, due to which the transistor acts like a switch in on state. So all the current passes to the collector, then to the emitter, and then to the ground, and that's why this LED gets no current, so it is off. That's all. For this circuit I need 2 diodes. So I'll use 1N4007 diodes here, 1 kilo ohm resistor, 200 ohm resistor, a transistor and an LED. As you can see from the circuit that the P terminal of both diodes are given logic. So I'll connect 2 red wires to show logic here and here. This upper one is A and this lower one is B. Okay. Now as we can see from the circuit, their N terminal are shorted together. So I'll connect a wire. Now from there, a 1 kilo ohm resistor is directly connected to the base of the NPN transistor. The transistor I'll use here is BC547, in which this terminal, first one, is collector, then base, and then emitter. Collector, base, emitter. Collector, base, and emitter. Now to the base, I'll connect 1 kilo ohm resistor. So you can see to the base, a 1 kilo ohm resistor is directly connected, and then the other terminal of resistor is connected to the N terminal of both the diodes. Now here emitter terminal is directly grounded, that means third terminal can be directly connected to ground. Okay. So here it is, the emitter terminal is directly grounded. Here you can see the collector terminal is connected to 100 ohm resistor and then to positive terminal of a battery. So I'll connect a 100 ohm resistor to the emitter, to the collector, So from collector terminal to positive terminal of the battery, I'll connect it from here to directly here, a 100 ohm resistor. Okay. Now a resistor of 100 ohm and LED is connected to the collector terminal again. So I'll just connect. Okay. So this is it. Now for output, an LED is connected ahead of this 100 ohm resistor. This resistor here and directly to ground. Okay, now I'll connect these two logic to 0 0. That means to negative terminal of the battery. Okay. Now since I have a 9 volt battery, I'll connect its positive terminal here. So for a NOR gate, if I give 0 0 input, I should get 1 output, and I've given. Now from the truth table, for 0 0 I should get 1, and I've connected both the inputs to 0, so I'm getting 1 output. Now if I connect 0 1, I should get 0. That means if I connect this 0 to 1, I should get 0, which is same as the truth table. If I connect B to 1 and A to 0, that means A to 0 and B to 1, again 0. If I connect both to 1 1, I should again get 0 output. So B is connected to 1. If I connect here also, I'm getting 0. So this is again the circuit. I'm getting 1 only when both the inputs are 0. It means if both the inputs are connected to negative terminal of the battery.